Hello, this is Brandon Mills with the Network Intrusion Detection System project for the Indigenous Youth Data Analytics internship. So our problem definition today was to look at the cybersecurity landscape and analyze the threats that come in. Large organizations have an extremely large number of packets that flow through a network. Even our sample contains 2.8 million records, and manual analysis would be nearly impossible. So our goal was to develop a supervised machine learning classification model to predict whether a network connection is benign or malicious. The intent would be to deploy this as a first line of defense on the network, like a firewall, to assist the security center by filtering traffic. Since we're working in a security context, we are going to prioritize recall alongside accuracy, since we want to minimize the number of false negatives, which would be malicious packets that slip through the detection model. Whereas optimizing for accuracy, we would be optimizing for just accuracy on both ends, whether it's benign or malicious. And in this data set, it's especially important to optimize for that recall, since there's such a smaller number of malicious packets compared to benign, which could skew it. So for our data set, we used the CIC dataset simulating a 5-day period in a business kind of network with a number of Ubuntu networking, or a number of Ubuntu servers on the network, as well as some Windows and Linux regular machines, as well as I think there was a Windows server. The 2 attacker machines was one Kali Linux system, as well as a Windows system. The original data set had 79 features, which you can see here. Using the project description, I used that to narrow it down to what we were told to focus on, which wound up being 17 input variables with 1 output variable. So for my actual notebook, I start by loading in the data, which just looks complicated because I did it through Google Drive. Then we define our columns of interest, which I just cross-referenced with the header column from the CSV, or the header row rather, against the project description, and defined the columns that were relevant, which I used to filter it out. For cleaning, there were a number of things to consider. There were nan and duplicate rows, since traffic was generated on the identical machines across multiple days, and it was also simulated. There were some identical packets that were sent out on different days, so we just dropped those to stop the machine from overfitting, as well as to stop duplicate records from filtering or leaking from the training data to the testing data, which leads to more memorization than actual prediction from the model. So after identifying the unique rows from the various anomalies, we drop all of the anomalous records. Since we have such a large data set, we still have a decent amount to work with, just over 2.2 million. And we also encode our label column. The label is stored as either benign or the type of attack, like botnet or DDoS, etc. So I could have muted that to add another column for attack type, but I wasn't sure how to consider that alongside the benign packets. Would it just be an attack type of none? I wasn't really sure. So instead, I just encoded all malicious packets as 1 and benign as 0, which gives us our binary categorization for the model. So here we separate the input and output features. Since we dropped all the duplicates as well as the malformed rows, we don't have to worry too much about that. We just have our X and Y, which is just the label column. We split the data. And for the model, since we have 17 input features, I just chose the nearest binary exponent number to as the maximum number of neurons and halved it down our 2-layer funnel. I also used dropout neurons, dropout layers. I'm not quite sure what the correct terminology is. But these turn off 20% of the neurons at random to try and help prevent overfitting. And after I added that, I did experience better recall scores. So I think I had some decent results with that. For our optimizer, we chose Atom with binary cross entropy for loss. And here's where we define what we are optimizing for, which we chose accuracy and recall. I didn't see significant differences between optimizing for recall or just accuracy, but adding both gave the best for both results. We used an early stop on our training. We just define a large number of epochs and our batch size. And we use this early stop for when the change stops being significant enough and there isn't enough of a delta between the values. It'll automatically stop the training and restore the best value. We generate our confusion matrix report, which tends to be between 95 and 98% accuracy and around 90% recall. And you can see here the number of malicious packets that slipped through with our 90% recall. And this is our number of benign packets that were classified as malicious. We got a decent balance here. And in my opinion, for a front line of defense, fully optimizing for recall could lead to a lot of benign packets dropped, which could lead to extremely poor performance outside the network. But yeah. So for the model evaluation, like I said, we got around 97% accuracy. We had a 93% precision, which is also quite good. It's better than the recall, which was interesting. No matter how I optimize this data set, perhaps because of the number of benign records compared to malicious, the precision just was always higher than the recall. And perhaps, like I could have tuned the decision threshold a little more, and that probably would have had an impact on that, but I'm not quite sure the best way to do that yet. I could try and generate a curve and manually do it, but I'm not, we haven't gotten there yet, so I didn't try and conquer that today. But overall, I'm quite happy with it. The biggest weakness with the data set, in my opinion, is a large number of the attacks. I'll just switch over to the page here. For almost every attack, the attacker is the Kali Linux system, which was operating from the same IP on certain days, which is arguably unrealistic. The victims also are disproportionately Ubuntu servers, which could be realistic. I don't have that kind of experience with network security. There was only one attack performed from a Windows system, and all the other attacks were from a Kali Linux system. But overall, I am happy with how it came out. Yeah, thank you very much for listening to my presentation. Yeah, have a good night.